Hello everyone. Now we will solve another example of linear programming problem. So now as we can see from this question, there are four variables x1, x2, x3 and x4. So in this case it is not possible to solve it by using graph. So we have to use it by the simplex method. Okay, so let's go to the first step. What is the first step? First step is to convert this into standard form. So how do we convert it into standard form? We need the function to be maximization, so it is already there, and we need to change the constants as equation. So let's do it. So it is maximization of z is equal to x1 plus 2x2 plus 3x3 plus 4x4 subject to the constants. Now constants we have to make equation. So let's take the first one, x1 plus 2x2 plus 2 times x3 plus 3 times x4. As this is less than 20, I want to make it equal. So to make it equal, we have to add a slack variable, and this slack variable will go with coefficient 0 in the objective function. If we take the second one, it is now 2x1 plus x2 plus 3 times x3 plus 2 times x4. Again I want to make it equal, so we add another slack variable. We name it as s2, again with 0 coefficient in the objective function. Now here, with the condition that all these variables x1, x2, x3, x4 and the slack variable s1 and s2 are non-negative. Okay, now let's move to step 2. Step 2 is to find initial basic visible solution. Okay, so how do we do that? We substitute the original variables, say x1, x2, x3 and x4 equal to 0. So what we will get from these two equations? First equation will give you s1 is equal to 20 and s2 is equal to 20. So this is your initial basic visible solution. Now we will move to step 3. Step 3 is to form a simplex table, which is actually first simplex table, for which we will draw lines. We make the table by writing down all the variables here: x1, x2, x3, x4, s1 and s2. Here the basic variable xp, here RHS, the right side. This is for Cj and here also for Cj. Now first let's write down the entries for Cj. The coefficient of x1 in Cj is 1. For x2 it is 2. x3 is 3. It is 4 for x4 and 0 and 0 for s2. So we have used this objective function. Now we have two basic variables s1 and s2 that we will write here, s1, s2. Now s1 is appearing in this equation, so the coefficient of x1 in this equation is 1. For x2 it is 2, x3 it is 2, this one. For x4 it is 3, s1 is 1, there is no s2 means 0, and RHS is 20, the right side, this number. Similarly s2 comes here in this equation. The coefficient of x1 is 2, coefficient of x2 is 1, then 3, 2, there is no s1 so 0, for s2 it is 1 and then 0, 20 there. Now the value of s1, s2 from the Cj, 0 and 0. Next we will calculate Zj. So how do we calculate Zj? 0 multiply 1, 0 multiply 2 and add them. That gives you 0. As both S1, S2 0, so this first row will come 0, all values. Next is Cj minus Zj. Cj is here on the top. 1 minus 0 gives you 1. 2 minus 0, 2. 3 minus 0, 3. 4 minus 0 is 4, and then 0 and 0. Then we have to select maximum from here. So this is the maximum value. So it means in the next table we have variable x4 incoming. Now as x1 is entering, we need to find which variable will be leaving. So for that we calculate ratio. Sometimes we denote it by theta. So how do we calculate? 20 divided by the number here 3 and here divided by 2. 20 divided by 2, it gives you 10. Here you will get 6.66. So from here we select the minimum. So it means variable S1 will be leaving, and this is the key row, and 3 is the pivot number. 3 is the pivot number. So let's do the calculation. So as x4 is taking place of S1, in new table we will write x4, okay, and S2 will be same. There is no change in the value in the variable S2. Okay, now we start working with the row for x4. So as by the formula, it is number in old row, that is 1 2 2 3 1 0 20, divide by the pivot number, which is 3 here. Divide by 3, divide by 3, divide by 3, divide by 3, 3 and 3. So now here it's up to you. Either you convert it into decimal number or keep it same. For me, I am keeping it same. Just 3 divide 3 is 1 and 0 divide 3 is 0. Now we will do the calculation for S2. So what was the formula for that? So the formula was new row equal to old row minus number above or below the pivot, and then multiplied by the number in row of new table. So old row means the row corresponding to S2 in the previous table, which is 2 1 3 2 0 1, minus number above or below the pivot. Here this is the pivot number below, so which is 2. So 2 multiplied by the number in new row, means the row corresponding to x4, which is 1 over 3, 2 over 3, 2 over 3, 1, 1 over 3 and 20 divide 3, which you solve, you will get this number. So let's write down here 4 over 3 minus 1 over 3, 5 by 3, 0 minus 2 by 3 and 20 by. Then we write the corresponding value for x4, it is 4. For S2 it's 0. Now we have to calculate Zj. So it is 4 times 1 over 3, that is 4 over 3 plus 0 times something, which is 0. Similarly here we will get 8 over 3. Here also 8 over 3. 4 over 3, 0 and 80 over 3. Now we will calculate Cj minus Zj. Cj is 1 minus 4 over 3. gives you minus 1 over 3. 2 minus 8 over 3 gives you minus 2 over 3. 3 minus 8 over 3 gives you 1 over 3. Here 0, minus 4 over 3 and 0. Okay, you can even use calculator to calculate these values. Now you shall see this is the maximum value, which is positive. So it means in the next table x3 will enter the basis. Now we need to check which one is leaving. So this is the pivot column. Okay, so this is 20 divide 3, this whole divided by 2 by 3. Here 20 divided by 3, this whole divided by 5 by 3. So when you work on it, here you will get 10 and here 4. So here you will be selecting minimum, which is 4. So it means S2 is leaving, and this is your key row. And what is the pivot number here? Yes, 5 over 3. This is your pivot number. So now the position of x4 is same. In place of S2 we are getting x3, and then we will do the same calculation. So it means we have to divide this entire row 4 over 3. Let me write it here so that it will not look complicated there. So we have old row as this is for x3. So we are having 4 over 3 minus 1 over 3, 5 over 3, 0, minus 2 over 3, 1 and 20 over 3. This is divided by the pivot number, which is 5 by 3, 5 by 3, 5 by 3, 5 over 3, 5 over 3, 5 over 3, 5 over 3. So 4 divide 3. So how it works actually? 4 divide 3 and then 5 divide 3. So it will become 3 by 5. Cancel. This gives you 4 over 5. This is 4. Okay. 4 over 5. In the same way, when you calculate this, you will get minus 1 over 5. Here you will get 1. Here 0. Here minus 2 over 5. Here 3 over 5. And there 20 over 5, which is nothing but 4. So let's write down these numbers here for x3 column. This is 4 over 5 minus 1 over 5, 1, 0, minus 2 over 5, 3 over 5 and 4. Now to find x4, we will again make use of this formula. Okay. So how it will work? For x4, right? x4, no? Yeah, x4. So number in old row is 1 over 3. Let me write with blue. 1 over 3, or let me write it in this way. 1 over 3, 2 over 3, 2 over 3, 1, 1 over 3, 0, 20 over 3, minus number above or below the pivot. Here pivot and the row above, so number above, which is 2 by 3. So it's 2 by 3 in all. Okay. Multiply by the number in the new row, which is this one, row corresponding to S3. So which is 4 over 5 4 over 5 minus 1 divide 5, 1 minus 2 over 5, 3 over 5, and here 4. When you simplify it, see, don't do mistake. You can even use calculator for this purpose, because if you do small mistake here, it will disturb the complete solution. So we will get this number. Now we will enter this row here for x4. Now we will write down the cost for x4. It is 4, and for x3 it's 3, which we require to calculate zj. So in the same way, 4 multiply minus 1 over 5, 3 multiply 4 over 5, and when we add them, we will get 8 divide 5. Here similarly 13 over 5. Here we will get 3, 4, 6 divide 5, and here 1 divide 5, and here 28. Next we calculate Cj minus Zj. Cj is this top row minus Zj. So Cj minus Zj. 1 minus 8 over 5 gives you minus 3 over 5. 2 minus 13 over 5, which gives you minus 3 over 5. 3 minus 3, 0. 4 minus 4, 0. 0 minus 6 over 5 is negative of this, and 0 minus 1 over 5 negative. So what we can see here, all Cj minus Zj are either negative or 0. So we reach the optimal solution. So the solution is optimal. Now when we want to write down the solution, what it will be? Now in the final table, we have only two variables, x4 and x3. So we have non-zero value for these two, x4 and x3. And what is the value? Value from here, the right hand side. So their value is 4. Other variables x1, x2 not there, so their value is 0. With the maximum value of z is 28. This is the value of z. So this is your solution.